What is arc flash? This is what we call arc flash. A release of heat energy due to an electrical short circuit. Many don't know this danger. Unlike a shock, current does not touch you during an arc flash. However, current creates intense light and heat. The intense light can blind you and the heat could fatally burn you. The temperature during the heat energy released could reach 35,000 degrees Fahrenheit. 35,000 degrees Fahrenheit is 3.5 times the temperature of the sun's surface. Insanely hot. Arc flash is a particular type of short circuit phenomenon. Short circuit is the cause of most electrical fire. Short circuit means current flows somewhere it is not supposed nor designed to flow, and the new unintended path has extremely low or no resistance. Look at those energized conductors inside an enclosure. We have two conductors. Current is designed to flow in the left conductor and in the right conductor. Suppose, for some reason, an object falls here. In that case, current is now forced to follow two paths. Path 1, intended path. Path 2, unintended path. The new unintended path is the screwdriver, the foreign object. The screwdriver has very low resistance, a short circuit. There are several other causes of short circuits. Ohm's law states that V is equal to R times I. Then I is equal to V over R. V is voltage and R is resistance. So if R go extremely small, like in a short circuit, and V barely changes, the fraction V over R will significantly increase. This is why current values significantly increase when there is a short circuit. Those new current values are so high that they could cause massive damages. Electrical fires, disintegration of several equipment components, explosion, extreme stress in electrical equipment, and so on. In the case of arc flash, when a short circuit occurs, current also flows in the air and inside the solid material. In our screwdriver example, if there was an arc flash, current would flow in the screwdriver and in the air gap between conductors or between conductors and ground. I said air, but arc flash occurs not only in the air but also in many gases and vapor. I will use air in this video because that condition is more predominant in the industry. In nominal conditions, the air is a perfect insulator and current cannot flow in the air gap. However, a tremendous amount of energy is supplied to the air when there is a short circuit. Current can then jump in the air gap between conductors or between conductor and ground. When current does so, it ionizes the air. When the air gets ionized, an electric arc is formed. The term arc in arc flash comes from the word electric arc. The term flash in arc flash comes from the flashing effect of that intense light, like a camera's flashlight. That visible plasma is what we call an electric arc. If that arc is not removed very quickly, the condition worsens and the arc turns into an explosion. Intense heat, intense light, extremely high temperature, and flames. This is an electrical arc. It is not different than the electrical arc on an arc flash incident. However, during welding, the electrical arc is controlled and intended. Therefore, that arc does not lead to an explosion. Lightning is another electrical arc that comes from nature. This one is more complex and occurs when two electrically opposite charge regions grow large enough in the cloud. Lightning releases millions of volts. First, if no one is around when an arc flash occurs, there is no risk of hurting someone. Unfortunately, in practice, we will often encounter situations where we will need to have energized conductors exposed around workers. Absence of voltage testing, troubleshooting, racking in and out breakers, opening and closing enclosure for quick inspection, and so on. That's where an arc flash mitigation occurs because we can no longer eliminate the risk in those situations. To be clear, our task is not to prevent arc flash incidents. Our task is to significantly lessen the likelihood of someone being hurt considerably when an arc flash incident occurs and when the person is next to the exposed conductors. We must mitigate. When an arc flash occurs, the danger is the heat energy. The technical term is incident energy, measured in calorie per centimeter square. Notice there's a denominator centimeter square. In practice, we are too lazy and say calories, and even shorter, cal. The higher the cal, the more you can get burned. How far should anyone wearing street clothes be from the equipment to be considered relatively safe? That distance is called arc flash boundary. If you need to perform electrical work, is there anything you can wear to significantly reduce the potential burn? Task 1. Determine the calories number. Standard IEEE 1584-2018 tells us how to do it. Task 2. Determine the arc flash boundary. Standard IEEE 1584-2018 also tells us how to do so. Task 3. Open the NFPA 7E 2021 books and read those tables 130.5G, 130.7 C15A, and or 130 C15B. If you need to be inside that arc flash boundary, that table guides you in what personal protective equipment to wear to be relatively safe. Task 4. Anyone not having adequate PPE must be outside of the arc flash boundary. I just summarized in 4 tasks what is an arc flash study. Moreover, the results found on those 4 tasks are printed on an arc flash label. How easy was that? Now you know about arc flash study and arc flash label. Task 1 and Task 2 require in-depth knowledge of power simulation software, understanding electrical power theories, protected devices, and how to read and interpret drawings. Calories are a function of many parameters: short circuit current values, the time before the fault current is removed, enclosure dimensions, equipment conductor's shape, and a few others. Once your equipment is purchased and installed, there are only 3 variable parameters: current, time before fault current is removed, and working distance. Working distance is the distance from your chest and head to the exposed conductors. Working distance becomes fixed when your electrical safety procedures in your facility establishes what distance to use for all electrical work. So it comes down to 2 variable parameters: short circuit current and time before the faulty current is removed. This video shows current data coming from a worker's tragic death in California, USA during an arc flash incident. Those data were recorded by the relay. You can see 3 current values, and the current graphs are here. Right now, we are scrolling every millisecond before the fatality occurs. 8 hours, 20 minutes, 23 seconds, and milliseconds here. Look at this exponential jump. Arc flash fault is occurring and new current values are about 4900 amps, 22 times pre-fault current. Now I will show how many calories for this event. We know the fault current about 5000 amps. Now we need time before the fault current was removed. The fault starts here at time 8 hours, 20 minutes, 23.941 seconds. The fault ended here at times 8 hours, 20 minutes, 25.671 seconds. You can see currents went to 0 after the breaker opened. Duration is end time minus start time. If we do the math, 8 hours, 20 minutes, 25.671 seconds minus 8 hours, 20 minutes, 23.941, we get 1.73 seconds. I use a tool on ETAP software called Arc Flash Calculator. I already populated all the fixed parameters from that facility. Now I'm going to input the current here and time. As I input the current and time, I want you to see how the incident energy value will change. The current was about 5000 amps. The time was 1.73 seconds. Now see, about 42 calories. After investigating this tragic death, they could not determine what went wrong. All the equipment was inspected after the incident and they tested and worked properly. The worker had the proper PPE before the incident. The PPE was in excellent condition before the incident. Why was he fatally burned? Guess what? The current and time in the simulation were significantly different than what occurred in real life. The engineering studies results were incorrect. The worker wore a PPE for less than 12 calories, while the total calorie number was 42. 98% of electrical and arc flash studies that I have verified had similar issues. Simulation short circuit current values and time significantly different than real life. 20,000 arc flash levels significantly wrong. Moreover, every time I find flaws in the simulation, I rerun the studies to show how the new current and time values closely match the field values. Anybody with a software license can run electrical arc flash studies and give you a result. Still, it does not mean those results are accurate. That is the sad state of this discipline, fake accuracy. Thanks for joining me. Merry Christmas to the Christian and happy holidays if you are not Christian. I am Chiri Pasa and I approve this message.